Water treatment plant operators work diligently to produce water that is safe, clean, and suitable for consumption 24 hours a day, 7 days a week, 52 weeks per year. Treatment plant operators use a variety of techniques and methods to provide an uninterrupted supply of potable water for their family, friends, and neighbors. How is it then that a 60-year-old resident in an Alabama city has his skin blistered by a strong caustic solution while taking a shower in his home? Or kidney dialysis patients inadvertently receive water mixed with ethylene glycol and antifreeze additive, resulting in 2 deaths and others being sickened. Or chlordane, used as an insecticide, is drawn into a water distribution system throughout a neighborhood. Or a dozen children at a vacation Bible school experience dizziness and nausea because they are served Kool-Aid laced with chlordane. Each of these episodes is a real-life example of a cross-connection backflow incident. Cross-connection is an interconnection, either direct or indirect, through which the potable water supply is exposed to a non-potable source of contamination or pollution. Backflow is a flow condition induced by a differential in pressure that causes the flow of unwanted substances into the potable water supply system. Backflow can be caused by either back siphonage or back pressure. A back siphonage can arise from a main break. For example, a driver inadvertently runs into a fire hydrant, knocking it off the base. The hydrant is located in a low spot in the distribution system. The normal situation in a distribution system is the higher pressure in the lower elevations forces the water up to the higher points. Once the hydrant is severed, the pressure drops suddenly, and the water flows from the higher elevations to the lower point. In addition to the dirty water created by the reverse indirection, the retreating water may actually create a siphon effect, drawing unwanted substances into the system wherever they may be connected with the water supply. A back pressure situation can develop from excess pressure generated in a hot water heater. As water is heated, it expands, creating pressure in the process. Once again, the water will flow from the area of higher pressure to the lower pressure. If there is not a device in place to prevent the disruption in flow, the customers of a water supply system may be exposed to potentially harmful substances within their water supply. The need for a cross-connection control program may take many of your customers by surprise. Another issue in the cross-connection arena is the cost. A significant portion of the cost of a program is usually passed on to the customers. Prices vary from the relatively inexpensive residential device to several thousands of dollars for installation in larger, more critical applications. In addition, some devices will require annual inspections and ongoing maintenance expenses beyond the initial costs. For this reason, it is essential for the water companies to begin a public education and awareness campaign, informing their customers of the need for such a program. Some of the methods of getting the information out are public information announcements on local television and radio stations, and newspaper press releases from time to time. All of the utility representatives who will be interacting with the public should have a good understanding of the importance of the program, the scope of the project, including timetable for implementation, costs of the various options used in cross-connection, the inspection frequency, and the procedure to be taken in cases of non-compliance. The Department of Environmental Protection is authorized under the Pennsylvania Safe Drinking Water Act to establish standards for the construction of a water supply to assure compliance with the provisions of the Act. Accordingly, Section 109.608 of DEP's Rules and Regulations requires that a water supply may not be designed or constructed in a manner which creates a cross-connection. In addition, Section 109.709B further requires that, at the direction of the Department, the public water system shall develop and implement a comprehensive control program for the elimination of existing cross-connections. Individual water suppliers may need to adopt a local ordinance. The water supplier should do a survey of their system as soon as possible. The idea is to identify those facilities that pose the greatest hazard in the most vulnerable sections of their system. One method to accomplish this is to divide the customer base into 3 groups: hazardous facilities, aesthetically objectionable facilities, and non-hazardous facilities. Then, review the distribution system records and maps to identify areas of chronic low pressure and frequent main breaks. Combining those 2 categories can provide a rank to list areas of concern. The first priority would be the hazardous facilities in the most vulnerable sections of your distribution system. The second priority would be the hazardous facilities in the less dangerous areas of your system. Third would be the aesthetically displeasing sites in the hazardous area, etc. The next step is to notify those customers in the highest priority of the requirement for control. The notification could be in written form and followed by a face-to-face meeting. All parties should be clear on the timetable for completion and the type of device to be installed. Once again, the device must match the potential for hazard. A simple double check valve is not suitable for application where a toxic contaminant could get into the water supply. We have mentioned backflow prevention devices at various points throughout this video. The backflow prevention devices are various mechanical plumbing arrangements designed to prevent backflow and back siphonage from occurring. They range from simple, straightforward to the complex multi-barrier types, and they vary in effectiveness as well. In selecting devices to be used in various applications, keep in mind that it is vital to match the degree of protection to the degree of hazard present. It is also important that the limitations of each device be understood, since the degree of protection provided will depend on the type of protection device chosen and the maintenance program employed. Some backflow prevention devices used for cross-connection control are the air gap. This is the safest, surest way to avoid cross-connections. An air gap is a physical separation between the water supply and the contaminant. Here it is the distance from the highest possible level in the sink and the tip of the faucet. The recommended distance for the air gap is double the diameter of the pipe delivering the water. In no case should the air gap be less than 1 inch. The operator also needs to ensure that safety is not compromised by carelessly adding a length of hose or some other apparatus which defeats the purpose of the air gap. A major drawback to an air gap is a loss of system pressure. Because there is a loss of system pressure with the air gap, the cost of reinstituting pressure by overhead tanks or installing a tank and pumps may be prohibitive. Double check valve assembly consists of 2 independently acting, soft-seated, spring-loaded check valves mounted in series with 2 tightly closing shutoff valves and 4 test ports. The primary advantage of a double check valve assembly is that when the 2 check valves are wide open, there is relatively little resistance to flow. They prevent backflow by both back pressure and back siphonage. Because the double check valve assemblies lack the differential pressure relief valve that reduced pressure zone devices have, they are recommended only for non-health hazards. They also could fail to function while not giving any outward indication that failure has occurred. Reduced pressure zone devices consist of two soft-seated, spring-loaded check valves operating in series and a soft-seated, spring-loaded, diaphragm-activated pressure differential relief valve located between the check valves. These devices will indicate leakage through one or both check valves or the relief valve by the discharge of water from the relief valve port. This is an important advantage over the double check valve assembly. This device is recommended for hazardous materials that present health risks. One of the drawbacks is a significant loss of pressure across the device. The pressure drop may range from 10 to 30 psi, depending on the size of the apparatus and the flow rate. The residential dual check valve is a practical, non-testable device that can be installed for containment protection at residential homes. Because it cannot be tested, the residential dual check valves are recommended for non-hazard applications. The RDCV is installed in line and downstream of the service meter and contains no shutoff valves. In summary, a comprehensive backflow prevention program is not only required by regulation, it is the right thing to do. Every water system is susceptible to a backflow incident, and backflow episodes can be costly in terms of life and health, both financially and legally. Every system should institute a backflow program if they haven't already done so. When reviewing and approving proposals for backflow prevention devices, ensure that the proper device is specified to match the degree of hazard and that the monitoring and maintenance programs are appropriate and ongoing. For more information on cross-connection backflow prevention, systems can contact their local sanitarian or public health department. Help in developing a cross-connection program is also available from various organizations, such as the Pennsylvania Rural Water Association, the American Backflow Prevention Association, and the New England Water Works Association. A well-thought-out and properly implemented backflow prevention program will go a long way in preserving the quality and safety of the best drink in town.